Hey there, awesome physics students. Let's talk about fluid pressure. First of all, what is a fluid? A fluid is any material where the atoms or molecules are allowed to move past each other freely. So an example of a fluid is anything like air is a fluid. Any gases are generally fluids. And also water is a good example of a fluid. Generally, liquids are fluids. Solids are not fluids because the atoms are stuck in a regular spacing and they can't move around freely. Okay, so what is pressure? Well, pressure is defined as the force per unit area over which the force is exerted. So force has units of newtons, area has units of meters squared. So a pressure unit is going to be newtons per meter squared. We call this pascals after Blaise Pascal. So we usually abbreviate it like PA. Notice that this has the same units as stress when we talked about stress and strain. They're also measured in pascals. Okay, so what is a common measurement of pressure? Well, there's air pressure. That's because of the weight of the air pushing down on all of us. And one atmosphere is, a standard atmosphere is 101,325 pascals. So this makes Pascal kind of an awkward unit in some sense, since this is the air pressure. What actually causes pressure in the air? Well, pressure in general is whenever you have the interface of two, like a solid and another fluid, or two fluids. But anyway, you have a surface here, and the fluids are made of molecules or atoms, particles that are free to move around, and they're going to move in all different directions. And what's going to happen is they're going to strike the surface of the fluid and bounce off. And when they collide and bounce off, they transfer momentum to the surface, and that is a force. And the more concentrated that force, the more collisions per surface area, and the more intense those collisions are, the bigger the force will be and the bigger the pressure will be. So really what ultimately causes pressure is collisions from the surface. So you can't achieve a negative absolute pressure because the least force you could have from these collisions is zero collisions. So there's no such thing as a negative absolute pressure. All right, what about some intuition? What can you do to get some intuition about pressure? Well, you already have some intuition about it. Imagine you take a pin with a sharp tip and you push on your finger with it. It's going to hurt. And the reason it hurts is that this is a certain amount of force, not a huge amount of force, but it's distributed over a very small area. That's the area of the tip. If instead you push with the same force over a larger area, that's going to hurt a lot less. And so that should hopefully give you some intuition about pressure. So that area term is, if that area is larger, then that pressure is going to be generally smaller. The other important thing you need to know about pressure is that it pushes in all different directions. So if you have like a glass of a liquid, the liquid is pushing down on the bottom of the glass, but it's also pushing on the sides of the glass in both directions. And generally, the force of the fluid is going to exert a force perpendicular to the surface because the pressure is in all different directions. It's both up and down in all different directions. So if you had like a flask like this, and you had some fluid in it, it's going to be exerted down on the bottom, but it's also going to be kind of exerted at a perpendicular to the surface here. So part of that force that it's exerting is a little bit up. And if you had a more extreme example of this, like if you had a glass that was shaped like a boot, then you might have, the force is going to be down on the bottom, but on this part here, it's going to be up. So in general, you need to remember that the pressure is exerting a force in every different direction. And when it encounters a surface, it's going to be perpendicular to that. The force is going to be perpendicular to that surface. All right.